so that might be like a shape, you know, a two-dimensional shape. This might be like y equals x, and then you got some kind of parabola here. And then what they're going to do is revolve it around, this will revolve around the x-axis. And this is like a representative strip that's revolving around right now. But in reality, like the whole thing would be. They're just kind of showing you an example. So it makes a washer. And if you look at what we have there, I wonder if I can pause this. Click. Is that pause? No. Awesome. That's alright. Just another example. That's only half of it. It would actually go like all the way around. But just giving you an idea of what they look like. This would be, I believe now they're going to take the whole region and go around. It's a little slower than I would like it to be, but it's okay. You kind of get an idea of what I'm trying to show you, though. They're hard to draw. Some of them are hard for me to visualize. Some are easier than others. Here's just another example. This is a pretty common one. This is like y equals x squared on the bottom and y equals the square root of x on top. Revolve it around, you know, whatever. We can revolve it around the x-axis, y-axis, any horizontal or vertical axis. When you get into Calc 2, you'll revolve it around diagonal axis. We don't do that in this class, but you can. So this makes kind of like a bowl, you know, like a satellite dish type looking thing. So then our job is to find the volume of those. So, the formula's on the board over there. I'll write it on this paper too, but for now, everything's going to be up over there. So volumes of revolution. And right now, we're going to go around a horizontal axis. Formula is pi, and I want to get into and show you why there's a pi there in a second. I called Mr. Packard last week to ask him farther or further. I forgot the answer. I can measure it. It's farther. He's going to make fun of me because I called him a week ago. I'm trying. I don't know. He's not going to answer because he's teaching.
Hello, this is Chris Packard. I'm not available to call the phone right now, but if you leave a message,
I think it's farther. Shouldn't you guys know this? Aren't you an AP?
I think farther is a measurement. Further means like it like going on. Like
Yes, I think you're right. We're going to go farther.
Yeah, farther. I'm pretty sure.
Farther as you can measure it. I'm pretty sure.
I've memorized this so many times.
Yeah, same.
No, you know what? Farther.
I know farther is better.
It's my final answer.
It's like two further.
Yeah. Final answer. Big money. Are you sad?
I'm sad you didn't pick up.
I'm sad.
Sorry about it later at 6 hours.
So this is like that one they just did. Kind of looks like a satellite dish-ish thing. And I want to show you why the formula is the way it is, because I think that'll help you remember it rather than just like here, memorize this, you know. So the T minus B represents top minus bottom in both of these cases. I capitalized this one because this is the outside farther radius. Is it?
Yes,
Okay.
physical distance.
Okay. So what we're really doing here if I told you to find the size of the shaded area, so we're not doing volume, it's a two-dimensional figure. Find the size of the shaded area. So we got a big circle with a radius of 10, and then a small circle with a radius of 2. Do that first before we move on to the color. Find the size of the shaded area, so everything except for the hole in the middle. You don't have to like calculate it, but just look at it. What's the big circle? What's the area of the big circle? Not 10 pi squared. Pi 10 squared?
Same difference.
No.
No, it'd be 10 squared pi. Never mind. I'm forgetting multiplication rules. Don't judge.
Wouldn't the size of the shaded part be this?
Yeah.
This is your. So what I would call this is like your big R or your farther or your outside shape. Like it's farther from the middle. And this I would call your little r or closer or inside. Well, if you turned this sideways and slapped it on here, when you rotate this around, isn't it just making a bunch of really thin versions of this? You see that? So like this part here, if I just break it down and look at like this little strip, just take one little strip in the middle, and that gets revolved around the x-axis. Wouldn't it make this shape? It'll have like a circle, like this will make a big circle around the outside, and this will make a little circle around the inside. And then if you found, you know, the shaded part, that would give you the area of that little strip. Does that make sense? Well, what's the size of each of those little strips? Okay, let's back into it. How many of those little strips are there?
Yes.
An infinite amount, right? How wide are they each? The limit of the width approaches 0. The way the width is represented is dx. So this is technically the width of each of those little strips. So what we're doing is you've got this little strip, and there's an infinite number of them, and we're going to add up the areas of all those strips. If we add up all those areas, we will get a three-dimensional polygon. So that is why. So this. This is just pi. That is like pi times the big R squared. And then this is like pi times the little r squared. You're just doing pi r squared minus pi r squared. That's all this is. The radius is going to be the distance, which is the top minus bottom. I know you're totally confused right now. I'm okay with that. So let's look at like how I would set this one up. I think it'll start to make some more sense. First thing you do, just like you do with the areas, is find where they intersect, right? So what do I do with those two equations to find where they intersect? Sine of equal to 0. This is going to be 0 and 1. I'll just tell you, it's just easier. So your volume is going to be, so it's pi. Every time you're revolving, you're going to have a pi there, because when you revolve, what shape do you make? You're making circles. That's kind of the point I was trying to make, but I was making it way harder than that. You're making circles, so there's going to be a pi. Now, you're going to have, I can kind of start that general setup. And so here's the question I ask myself on every one of these. I can put the minus in there too. which I'm revolving this one around the x-axis. Which equation is on the outside of my shape? Which equation is further away from where I'm revolving? Those are the same question. Which equation is on the outside? If I rotate that around the x-axis, which equation is on the outside? I'm sorry, people were sneezing while I was trying to teach. I couldn't hear the answer. Which one's on the outside? Square root of x. What is the equation that we are revolving around? You can't say x-axis, that's not the equation. Can't say x equals 0, that's y. Y equals 0. Okay, so, which one's farther away is the square root of x? And then the next question is, what's the distance between the outside equation and the axis of revolution? The distance between any 2 points, if I'm looking like vertically like this, is always top minus bottom. You know, if I have a dot at 10 and a dot at 6, how far apart are those? Seriously? 4! How did I get 4? 10 minus 6. Good job, Mr. Davis. If I have 2 and negative 2, how far apart are those? 4. How'd you get that? 2 minus negative 2. Top minus bottom. Even if they're both negative. Negative 5 and negative 9. How far apart are those? 4. Negative 5 minus negative 9. Top minus bottom. What?
I keep thinking you were going to change it, like the answer wasn't going to be 4, and I was going to be wrong. It's like,
Oh.
addition and subtraction.
I wasn't trying to trick you with subtraction. I'm trying to make a point that it's always top minus bottom. So how far apart? What?
It's always
It's not always. How far apart are the square root of x and 0? The square root of x minus 0, right? Top minus bottom. This will be the square root of x minus 0. So this is your further. This is the one that's on the outside of where we're revolving around. It's the one that's further away from the axis. Farther away from the axis. So you can look at that either way. It's the outside, or it's the one that's farther away from the axis of revolution. Over here, it's the other one. So which one's closer to where we're revolving around is y equals x squared, right? And what's the distance between x squared and our axis of revolution? X squared minus 0. And that's your setup. And then you can type that in. A couple things that you need to know here is that they will very often on the AP test ask you to just set these up. Like they don't even really care what the answer is because they're like, oh, we know you can type it in your calculator, just set it up. So technically, the order here wouldn't really matter because if I'm going to square it, it's going to come out positive anyways, right? But when they ask you to just set it up, they're looking at your order. So you can't just like shortcut and be like, oh, I don't care, I'm going to square it anyways. You have to do the top minus the bottom and the top minus the bottom. So this is your farther away top minus bottom and your closer top minus bottom. Yeah.
Is this another case where if you reverse your, I guess, further closer top minus bottom, would it just be wrong, be the same but come out negative? Or
Yeah. But if they ask you to just set it up,
I can see that that's a problem.
Yeah, they catch
if I have to
right?
calculate it for like you in the next upcoming week rather than maybe that's in the coming month.
then it'll be okay. But I'm going to do the same thing. I'm going to grade it just like they do. So I'm going to give you a test that's like, here, set this up, set this up, set this up. Okay, find this one. Let's set most of them are just set up.
Okay.
Alright, now we're going to blow your mind here. Now we're going to go around the horizontal line, y equals 4. So this was part A. Part B, we're going to go around y equals 4. I can still set up my general form here. Why is there a pi there? Because when I revolve things, I'm making circles. 0 to 1 are my intersection points, just like they were a second ago. But now, what's farther away changes, and your top minus bottom changes. Y equals 4 is up here. We got y equals the square root of x. We got y equals x squared. Which one, so I'm going to revolve this around y equals 4 now. Which equation will be on the outside, slash which one's farther away from the axis of revolution? X squared. Because that's the one that it's a bigger distance from there to there than it is from there to there. Now, how far away are 4 and x squared? Minus x squared. Top minus bottom, right? So the difference is now the 4 is on top and the x squared is on the bottom. So this will be 4 minus x squared. Which equation is closer to the axis of revolution, or which one will be on the inside? Square root of x, how far away are 4 and square root of x? 4 minus root x. And that'll be your setup, and if I asked you to type it in, I think you can do that. Questions on either of those two? Where's this coming from? What's going on here? Why is it in this order? Yeah.
Kind of a general question. Without graphing them, how do you know which one is closer to the axis you're looking at?
So typically on these, they give you a graph.
Okay.
I don't want to say always, because I'm afraid they'll be like, you said it wrong. Almost. I've never seen them not. Let me say it that way. Doesn't mean they won't, but if you really needed to, plug in a number between 0 and 1, like say plug in 0.5, and do the square root of 0.5 and 0.5 squared and see which one's higher, and that'll be your top. Livingston, what's up? Okay. Any other questions on this example? Alright. Let's do... So this can look a little different. Let's say it's y equals x squared. And y equals 9. I got this area. Part A, I want to revolve it around the x-axis. There's going to be a part A, B, C, and D here. There's going to be 4 parts. We're just setting up, so they go somewhat quickly. So what's the first thing I need? You said something, and then I said what, and then you just put your hand down. Oh, okay. So I gotta go, okay, volume equals pi. Why is there a pi? When we're revolving, we make circles. And then I make my integral sign. Don't I need the limits? How do I find those? Are the limits x values or y values? X values. Everything we put in this equation has to be an x value. So I want the two x values where those lines intersect. So what do I do? They don't intersect at 0. Not x values. Y equals 9. Y equals x squared. Yeah. Yes, thank you. X squared equals 9. What do you get? 3 and negative. That was mean. Alright. Now set up my... That's just kind of my general form, Then I gotta plug stuff in there. So it's like big R minus small r. The one that's farther away, or it would be on the outside of your shape. So I'm revolving this around the x-axis. So I'm picking this shape here, and it's going to come around this way, go back through the other side. That will actually have a really hard time visualizing these. Would it be this?
That one would be lighter, I would think.
But like generally, right?
Yeah.
It would kind of make this shape. You guys kind of see that? It's hard for me to see these.
This is where the cross section is.
Yeah, I work way better two-dimensionally, but okay. So which equation is farther away from the axis of rotation? Y equals 9. And how far away is it from? Let's back up. What is the axis of rotation? Y equals 0, right? How far away are the outside line and the axis of rotation? 9. I mean, it's just straight up 9, right? But if we're sticking with our general form, it's 9 minus 0. Top minus 5. That is the outside of your shape. The inside of your shape, well, which equation is closer to the axis of revolution? X squared. How far away is x squared from the axis of revolution? Square root of 0. Is that set up okay? For B, we're going to go around y equals 9. So this one's a little different because we're on the line. Set up my general plan. Alright, so think which equation is on the outside. Which one's farther away from the axis of revolution? And our two equations, like y equals 0 isn't even involved anymore, right? That was only because we were revolving around the x-axis. The only two equations I'm really concerned about now are these two. Which equation out of these two is farther away from y equals 9? X squared. How far away are 9 and x squared?
9 minus x squared.
9 minus x squared. So we're flipping it around this line. So the one that's farther away is this one, and the distance here between those is the 9 minus x squared. Well, which equation is closer to y equals 9? Y equals 9. How far away is y equals 9 from y equals 9? 0. I mean, so it's 9 minus 9 if I'm sticking with my form, but I don't have to subtract. What this piece is doing is subtracting out like the middle, like taking out the middle of the donut, you know? But is there a middle of the donut if I'm going around y equals 9? No. So you end up, like, you don't even technically have to write this part. You could just not put that, and it would be totally fine. I'm just giving you like a general form that you can kind of always plug in. So there's no, you don't have to subtract the inside because there is no. Let's go around y equals 11. Can you guys try it, or should I keep talking? Try it. So y equals 11 is above this shape, right? So way up there. You're right. I don't know if that was a look of confusion or like, I got this. Did you guys play Everbreak? Play this one? Probably start like these. It's supposed to be like 35 degrees. Alright, which equation is farther away? X squared. How far away is it? 11 minus x squared. You gotta do top minus bottom. And then which equation is closer? It's 9. And then how far away are 11 and 9 is just 2, right? But if you're doing sticking with the form, it'd be 11 minus 9 squared. So yeah, this is the equation that's farther away from our axis, and the distance is the top minus the bottom. This is closer to our axis, top minus bottom. How many have that? Okay. Questions I can answer on it? Let's go around. That's terrible. I like to try to make this shape as good as I can and judge myself on the shapes that I make. Let's go around y equals -1. that's below the shape. That guy that eats with you guys that has that laugh, did you hear me laugh? The guy that eats it, does he help coach too?
I think it's just a student.
He's a student teacher. He doesn't help with track, right? That laugh is very distinct. Alright, which equation is farther away? 9. How far away is 9 from negative 1? I mean, it's 10 away, right? But if I'm sticking with my pattern, 9 minus negative 1. Which equation is closer? Is the x squared. How far away are x squared and negative 1 to be top minus bottom, x squared minus negative. And so if it's multiple choice, they're probably going to do, they probably do this. So you see how I got from the first line to the second line there? Just squaring the, this would be 10, 10 squared is 100. So sometimes you got to simplify a little bit to get to what they wrote, but the general idea is right there. How many of that? All right. Questions? Yeah. Usually not really. Usually what the AP test will do is they'll give you that. Here's your two things. Here's a picture of them even. Find the area. So that's like what we did in the warm-up, right? Now, then that'd be part A. Part B would be find the volume revolved around whatever they decide. And part C would be find the area, or find the volume if we know the cross-section. So this is the next thing we're doing. I know this is more than you bargained for with your question, but let's say that there were little triangles sticking out of the entire shape. So I'm trying to make a three-dimensional drawing here. I'm not sure if I'm succeeding or not, but could you envision like triangles kind of jumping out at you? And then that'd be part C. So it'll be kind of one of each thing, and we'll go through all those. They don't really try to trick you with it. They're pretty straightforward about it. This is your homework. Like the first half-ish of these are just around the x-axis, and then I start moving the axis of revolution a little.